Good morning, STD-10 students. 8. As I explained in the class, machine chapter, mechanical advantage, term of the machine, mechanical advantage is load by effort. This one. Load, when we apply the force on machine to run the machine, then the work done by the machine, 8. So take an example of the pulley, single moving pulley. We apply the force in downward directions and we can lift a bucket of water from the bed. So here load is, what is effort? The effort, what force we are applying in downward direction. What is load? The load means bucket of water raised up to some distance. This is load. So mechanical advantage, as I explained you earlier, the mechanical advantage is equal to ratio of load to effort. Load have unit Newton, effort also unit Newtons. So cancel means mechanical advantage have no unit. Is clear? Now there are three conditions. What condition? When the effort is less than the load. I mean we are applying the effort less than the load. In this, it means effort denominator will be less than the numerator. In this case, the mechanical advantage will be greater than 1. And when mechanical advantage is greater than 1, this is known as force multiplier. 8. Force multiplier means apply the less force, overcome the large resistive force. This is the advantage of the machine given by the machine. We are applying the less force and overcoming the large resistive force. 8. So when it happens? When we apply the effort less than the load. Means suppose the load is 50 kg and we are applying the effort only 30 kg. So applying the effort 30 kg, we are able to lift 50 kg of load. So this type of example is known as in which mechanical advantage is greater than 1, and this type of machine is known as force multiplier. Second, when we apply the effort more than the load, it means denominator will be greater than the load. When denominator will be greater than the load, it means mechanical advantage will be less than 1. And less than 1 means it is known as gain in speed. This is known as gain in speed. So gain in speed, you can take example, force multiplier and gain in speed. Seizure and shears. Seizure, the cloth, to cut the cloth, we speedily we can cut the cloth with the help of scissors. 8. This is gain in speed. Shears, we are applying the less force and able to cut the metal sheet. To cut the metal sheet, we use the shears. So with the help of shears, we are applying the less force and we are able to cut the sheet, metal sheet, thick metal sheet. So this is the example of gain force multiplier. Means we are applying the less force and able to overcome the large resistive force. This is force multiplier in which mechanical advantage is greater than 1. Second, less than 1, that is gain in speed, like the scissors. Cut the cloth, we use the scissors. Speedily we can cut the cloth with the help of scissors. That is gain in speed. Third case, when effort is equal to the load. Means we are applying the effort according to the load. 50 kg of load, 50 kg of force we are applying. In this case, mechanical advantage will be equal to 1. Mechanical advantage equal to 1. There is no gain in speed, not a force multiplier. Then the question, why we use this type of machine? This type of machine we use only to change the direction of the effort of force applied. Because when I ask to draw a bucket of water from a well, you will apply the force directly in upward direction. But at the same time, when I ask you draw a bucket of water from a well by using the single moving pulley, easily you can draw. Right? Why? The reason behind it, it is inconvenient to apply the force in upward direction, but it is convenient to apply the force in downward direction. So when mechanical advantage is equal to 1, we use this type of machine only to change the direction of the force applied in convenient direction. You can say in convenient directions. Now, velocity ratio. Velocity ratio definition: velocity of the velocity of effort to the velocity of load. Since the body's velocity is equal to displacement by time. So velocity of the effort, say E is the effort and distance moved by the effort is d. 8. Velocity, distance by time. This one, the distance distance moved by the effort in t second and dl distance moved by the load in the same time of interval t. Then it will be cancelled. We will get d by dt. So velocity ratio is equal to d by dl. But don't write the definition. It is ratio of the distance moved by the effort to the distance moved by the load. Since it is velocity, what is velocity? So you have to express it in terms of velocity. Now we will explain. Velocity ratio is the ratio of velocity of effort to the velocity of load in the same interval of time. 8. This is the definition. Now again in velocity ratio, 3 conditions. First, velocity ratio is equal to d by dl. First case, when the distance moved by the load is more than the distance moved by first case, when distance moved by the load is less than the distance moved by the effort. In this case, velocity ratio will be greater than 1 and it is known as force multiplier. Second case, velocity ratio when dl, distance moved by the load, is greater than distance moved by the effort. In this case, it is less than 1 and this is known as gaining speed. 8. And third case, when equal, d and dl are equal distance moved, then velocity ratio is equal to 1. Same case as the mechanical advantage. Greater than 1, force multiplier means in this type of machine we apply the less force and overcome the larger resistive force. And second, less than 1, gain in speed. And third, equal to 1 means this type of machine we use only to change the direction of the force applied. Right? Or we can say indirectly in convenient direction. Actually, now, principle of machine. What is the principle of machine? Work output is equal to work input. Work done on the machine is equal to work done by the machine. If work done on the machine equal to work done by the machine are same, then it is said to be the principle of machine. And since the word is work, you know work is equal to force into displacement. The work output means work done by the machine. So L, DL and work input, work done on the machine means we are applying the effort and therefore due to this effort the distance moved, that is D. This is known as principle of machine. And there are two types of machine, means ideal machine. What is ideal machine? If output energy is equal to the input energy, I mean if work done by the machine is equal to the work done on the machine are equal, then this type of machine is said to be the ideal machine. Then we can say the efficiency of this machine is 100%. which is not possible practically. Is it? Once again, ideal machine means if the work done by the machine is equal to the work done on the machine, or we can say output energy is equal to the input energy, then we can say that this is ideal machine. But this type of machine is practically not possible. Okay? No machine has 100% efficient. The reason behind it, the first part, the moving parts is neither weightless nor smooth. This is the first condition. Why it is no machine is ideal? First condition, the moving part is neither weightless nor smooth. Second point, string in it not perfectly elastic. This is the second point. And third point, the different parts are not perfectly rigid. These are the 3 points. Because of this, no machine is perfectly ideal. Okay, some more topic that I will explain in the next video. Thank you.